So now that we know how to solve for system of equations and also system of inequalities, we are going to look at system of equations, but this time 3 variables. So let's kind of review a little bit. If we want to solve for 2 variables, so let's say x and y, then we need 2 independent equations. So we need 2 equations that represent different things so that we can solve for the 2 variables. So then if we want to solve for 3 variables, x, y, z, how many equations do you think we'll need? We need 3 equations. So what we're going to do now is we are going to look at how to solve equations, system of equations with 3 variables. So we need 3 equations. So let's look at this first question. We have a system of 3 equations. We have 3 variables. So we're going to solve, and this is the first method, which is by elimination. Okay, I'm going to first number these equations so it's easier for me to refer to them. So you're going to do the same idea as elimination with 2 variables, but this time, because there are 3 variables, it's hard to solve all of them at the same time. So what we're going to do is we're going to reduce the 3 variables into 2 variables. Okay, so if you look at the equations as they are, which variable do you want to eliminate from all equations so that it's easier for you to solve? Or just think about it, which variable seems easier to get rid of? Hopefully you noticed z is easy because they all have a coefficient of 1. It's just the sign is different. So what you can do is take 2 equations at a time and then eliminate z from both of them. So for example, I'm going to take equations 1 and 2. Equation 1 is 2x minus y plus z equals 4. And then equation 2 is x plus 3y minus z equals 11. And I'm going to add them together. You can see that the z's have the same coefficient but different signs, so this is easy. We're going to add straight down. 3x plus 2y equals 15. Good. So I got rid of z. I still have x and y. That's okay. I just want to get rid of 1 variable. All right, I'm going to take another 2 equations. It doesn't really matter which one. I'm going to do the same thing, add them together, and then get rid of z as well. So which 2 should we try? We can add 1 and 2. I'm sorry, we already did 1 and 2. We can do 1 and 3. We can do 2 and 3. We just cannot do 1 and 2 again. So maybe 1 and 3. 2x minus y plus z equals 4. 4x plus y minus z equals 14. All right, this one's pretty nice. 6x and then y and z both cancel, so 6x is 18. So x is equal to 3. This one's very nice because you can actually just plug it back in here to find y. So 3 times 3 plus 2y is 15. So 9 plus 2y is 15. 2y is 6. So y is 3. Last one, we need to find z. Doesn't really matter which equation you use. I'm going to put it into the first one. So the first one says 2x minus y plus z is 4. So when x is 3, y is 3, z we don't know, 4. Okay, so 6 minus 3 plus z is 4. So 3 plus z is 4, z is 1. So this means x is 3, y is 3, z is 1. But how do we write the answer? Just like system of equation, when you solved it, you had an x and y, and really what we're doing is finding where 2 lines intersect. This is the same. We're finding where the 2 lines intersect, or 3 lines intersect. And then when we have 3 variables, it just means it's like a 3D space. So instead of 2D plane, it's a 3D space. So it's going to intersect at this coordinate. this coordinate is 3, 3, 1. So please write your answer as a coordinate like this. All right, let's have you try this. Okay, you can see that here you have 3 equations and you have 3 variables, which is good. The question is, which variable do you want to eliminate? Looking at the way the equation is, the system is, might be easier for you to eliminate y. So let's have you pause the video and then eliminate y. So let me set it up for you guys. So then we end up with the same steps in getting to the answer. So take 1 plus 2. So equation 1 plus equation 2. And then also, let's see, do 2 and 3 since we're trying to get rid of y, and from those 2 equations you will get opposite signs for y. All right, so go ahead and pause the video. Go ahead and pause the video, solve the equation, and then come back and check your answer. All right, so you probably got to this point, and I'm not sure if you knew how to continue, but at this point, what's going to happen is we didn't get as lucky as the previous problem where we can just solve for a variable right away. We have 2 variables remaining, but luckily we also have 2 equations. So you can actually combine this together as a system of 2 equations, just like section 1 and 2. So the question is, how do you solve this? Well, elimination. So you have to pick a variable to eliminate. The question is, which one do you think is easier? I think x is easier to eliminate. So then if you look at the coefficient 2 and 3, the least common multiple is 6. So multiply this by -3, multiply this by 2, and then we get -6x minus 12z equals 12. 6x plus 10z equals -6. And then from here, solve for z, and then go back and then find x and y. So go ahead and solve this problem and come back and check your answer. All right, the answer is 4 to -3. The next method is called substitution. So what of course you can solve it any way you want, but some questions it's easier to use substitution. So if you look at the system, how is this different from the previous one, and how is it similar to the substitution questions that we had when we only had 2 equations? So recall when we were in section 2 and we said you can tell that a problem is easier to use substitution when there is a variable by itself. And you can see that is what's happening. You have x by itself, so then we can change this equation to x equals -5y plus 9. And then what we're going to do now is take this new definition of x, put it into the other 2 equations that have x. So this is called substitution because we're going to take that and substitute everything that has an x. So the first equation, again, I'm going to number them. So the first equation becomes 2 times -5y plus 9 plus 3y minus 2z equals -1. So first equation. The second equation is, the third equation is 4z minus 5 times the new x is -5y plus 9 equals 4. So let's simplify all that. Minus 10y plus 18 plus 3y minus 2z equals -1. All right, let's combine like terms. Let's see, -7y minus 2z plus 18 equals -1. Let's move all the constants to one side. minus 7y plus minus 2z, 2z equals minus 19. All right, let's look at the one on the right. 4z plus 25y minus 45 equals 4. Move the 45 to the other side. So 4z plus 25y equals 49. All right, now again, we have a system of two equations and two variables. That means we can solve if we continue to eliminate. So you can, oh, sorry, I probably should put them in the same order so it's easier to eliminate. 25y plus 4z equals 49. So you can see the whole idea is, if you have three equations, or meaning three variables, you reduce it to two and then reduce it to one and you solve for that one. So if you ever have four equations, it's the same idea. Reduce it to three, reduce it to two, reduce it to one, and then solve. All right, so we're at this point where we have system of two equations. So go ahead and solve and then plug it back in and find x, y, z as a coordinate. All right, you can see the answer is 4, 1, 6. All right, go ahead and give this one a try. So this one is kind of nice because it already tells you what b is. So you just have to substitute and solve for this one. So pause the video and come back and check your answer. All right, the answer is 2, 3, -2. Now let's look at two word problems. So since we're in the system of three equations, you can expect to have three variables in the word problem that you need to solve. So let's look at this one. You manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? All right, so I know that some of you may look at it and say, oh, budget of $6,000. This is kind of like the previous linear programming question where we're saying, oh, it's less than or equal to 6,000. I know it probably could have written this problem better, but in this kind of problem, or in this particular problem, they actually just want you to say equal to. So on the test, I'll make sure that it's more clear that this is a equal to problem, not a less than or equal to. Okay, in any case, you have three kinds of shirts, and the question is how many of each type of shirt? So each type of shirt is going to be your variable. So we have three variables: t-shirt, polo shirt, and rugby. Then we need three things, three equations in order to solve three variables. So let's take a look. First thing is we have this budget of $6,000. Okay, so we want to spend $6,000 is what they're saying. So we have to use all of it, not any less. So t-shirts cost $12 each, polo shirt is $24 each, and then rugby shirt is $36 each. And that total cost is $6,000. And then we want to restock 200 shirts. So that means x plus y plus z is 200. This is the third one. You have to have twice as many rugby shirt as polo shirt. So I get very confused when they say twice as many. So then what I usually do, so I always have problem with this one. So I always just ask myself, which one do I have more? Which one do I have more? Do I have more rugby shirts or do I have more polo shirts? Well, according to the problem, I have more rugby shirts. So rugby shirt is how much more than polo shirt? I have twice as much. So rugby is twice as much as polo shirt. So if I don't think this way, it takes me a very long time to figure out how to solve. So I just ask myself, which one has more? So then this one is twice as many, right? This is translation, is twice as many. Okay, now you ask yourself, how do I solve this question? Elimination or substitution? Probably easier to do elimination, right? So go ahead and solve using elimination and then check your answer. All right, the answer to this one is 20 t-shirts, 60 polo, and 120 rugby. All right, let's have you try, excuse me, the second one. So we're going to use the same information from the previous problem, but this time you want to have the same number of t-shirt as polo shirt, and then you have a reduced budget of 5,400. And then the question is again, how many t-shirts, each shirt should you buy? So go ahead and pause the video, write your constraints or write your 3 equations, and then come back and check them first, and then solve it. All right, the 3 constraints are x equals y, x plus y plus z is 200, and then 12x plus 24y plus 36z is 5,400. All right, go ahead and finish solving the problem. All right, the answer is 50 t-shirts, 50 polo, and 100 rugby.